We have on stage the illustrious Arun Gupta, who is a principal open source technologist, or as he says, post at AWS, and Sofia Parafina, who is a developer relations engineer at Docker. And you can find both of them on Twitter. Pretty active there. And if you ever use the Docker Labs repo or the Docker samples repo, they both contribute very closely to that. So please give them a warm welcome.
All right, my name is Arun Gupta.
And I'm Sofia Parafina.
We are very glad there are multiple sessions running right now, and we are thankful that you came to our session. We hopefully will make it worthwhile for you. Now, we saw the keynote this morning. Think about what are the typical challenges of a legacy app. I was part of the original J2EE 1.2 team. So how many people have bad memories of EJB? Yeah, that's a legacy app. That's a true legacy app. So I've been working with J2EE 1.2, 3, 4, Java EE 5, 6, 7, and then EE4J now. So I've been into the legacy environment for a very, very long time. What are the typical challenges? When the application was originally built, the developer is gone. The developer is no longer there. The source code is no longer there. We just inherited a WOR file or a jar file from somewhere. We don't know when was it last updated. We know this app is sitting somewhere in this monstrous WebLogic server somewhere, and I don't want to touch it because it serves a very critical functionality for me. However, modern applications are kicking in. When I'm doing my greenfield application development, then I have these needs. I want to be fast. If there is a change required in the application, can I make that change? How do I make that change fast enough so that it can go back to the market demands? I want the delivery time to be as minimal as possible. The change time in the application, if I have to change the business logic and be able to deliver it back to the market, should be minimal. I should be able to automate the application. I want to have the least amount of human interaction. I want to operate like Neo, where if I can do things, I'll just have a whole bunch of matrix around me and then let them do the job for me. I want to be able to scale the demand. Scale my application to demand if I need to. So, if horizontal scaling is what I'm looking at it essentially. Faster recovery. If a thing fail, break, I want to be able to roll back, upgrade, update, replace, patch. All of those requirements are very, very critical. High availability. That's again where your horizontal clustering comes in. And finally, last but not the least, is essentially automation. So these are typical needs of a modern application. Whether legacy or not legacy, this is what we are looking at in the business to stay competitive. So we believe that containers is the way to solve that problem. Typically, when people think of modern applications, they say, oh, I am thinking of microservices. Microservices is not a free lunch. It requires a lot of investment, both technological, psychological, organizational changes to go to the microservices route. But you have those legacy applications running where you can't change them overnight. So that's where exactly containers fit in. One of the biggest things that containers solve is the impedance mismatch. You have the exact same environment on your laptop. That's the exact same thing on on-prem. That's the exact same thing on cloud. So it works very well where it cuts down the impedance mismatch, exact same environment across and across. Your application dependencies, is no longer where you have to say, take this script, run this application server, run this JDK version, do this JDBC driver, have this logging driver. You don't do all that kind of stuff together. You just say, package all of this as a Docker file, and that's my source of truth. When you package your application as a container, it also cuts down your attack surface. If you're doing JDK as one thing, then you're doing application server as something else, then you're doing a Maven thing as something else, there are different points where you can attack. Now, with container being the source of truth, or image being the source of truth rather, your surface area on which the attack can happen is much lesser. And container is, again, built upon those hardcore Unix concepts, C groups, namespaces, and the way your volumes are mounted, those are extremely well tested, and so very limited number of areas where you can attack the application, essentially. Now, if you were to go with containers, yeah, a container is OK. But when you're building an application, that's where you get into the part of, oh, my application typically is going to be a multi-container application. If I'm doing a multi-container application, I need some sort of a platform where I can do orchestration. Orchestration is just one part of it, but then you need to build a full platform on top of it. You need the image where the registry where the image can be stored. You need some security scanning over there. You need to build a CI/CD platform on top of it. So orchestration is just one component of it, but there are a lot of other components that are required that are typically expected for you to deliver a modern application. Of course, with this morning's news, Kubernetes has always been a credible platform. But if you're looking at an orchestration solution, Kubernetes is an equally powerful orchestration platform, essentially. But if you were to compare Docker CE, which is a development environment on your MacBook, with Docker EE, which is your environment in the production, then that is not a fair comparison to Kubernetes. Kubernetes is just the orchestration piece of it. So a better comparison would be take a look at it, Docker EE versus OpenShift or something more similar, where it provides a platform on top of Kubernetes. And there are other platforms that you can take a look at as well. Now, of course, with this morning's announcement, this is the beauty of it. We have the way the container ecosystem works now, right from Docker itself. Whether it's Docker Mac, you have the Kubernetes and Swarm co-located, or whether it's Docker EE, you have, again, the same capability available over there. So hopefully you saw the demo that Ben and Christy gave this morning, how with UCP, with a single pane, you can see your Swarm clusters, your Kubernetes clusters, your shared resources. So that's the power that Docker EE essentially is now going to provide to you. Now, another set of orchestration, this is where my employer kicks in. If you're looking for, hey, I'm not into managing my own infrastructure, I want somebody to do the thing for me, then you can take a look at Amazon EC2 Container Service. Now, EC2 Container Service is a fully managed container service where you don't have to download anything, install anything. Amazon has this principle of operational excellence. So you just bring your containers, you deploy it on EC2 Container Service, and we have the entire set of capabilities around it. Registry, scanning, code pipeline, delivery mechanisms, all of those are very well integrated.
So Arun has given us a really good overview of legacy applications. And so, this is a big shift from what you expect from Docker. We've always said Docker loves developers, but now you're hearing of much more enterprise focus. But one of the things is that we really want to do is make developers' life easy. And by doing that, we want to modernize traditional applications within Docker. But what do we actually mean by that in terms of ROI? When you have to sell this idea. What we're looking for is cutting about 80% of the cost just to fuel innovation so that you can move these applications on to newer technology. So with Docker Enterprise Edition, it gives you legacy applications all the modern capabilities without actually recoding or refactoring of the application. So the things that we have built this program around is efficiency, where we want to optimize the capital expenses and operational expense costs and have a 50% reduction in those costs. We want to make this technology portable, so the infrastructure is actually independent of your application. We want to speed up deployment doing this, making 90% faster. And plus, we want to make it all secure. Nobody wants to be the next Equifax. So we want to reduce the risk and enforce all these new controls. We want to make patching of these of applications, patching of images 90% faster.
And one of the things I really like about this particular slide is, you may wonder, what are those numbers, 50, 90, et cetera? Those are real numbers that Docker has talked to their customers on where they are seeing those benefits. So it's not just a fake number. It's a full customer data, essentially.
So how do we realize these types of gains? So the first way we'll do is to eliminate outdated runbooks by creating just a simple Docker file. So before, you'll have VMs that contain a full instance of your OS, but however, containers will share a kernel of a single OS on a physical or virtual server. So what it does is, now that you're deploying more, since you can't actually deploy containers on VMs, as you well know, your average infrastructure consolidation could be 50%. Also, you can also take all these images that you build and check them into a repository so that they can be reused and shared in the enterprise. So part of this is streamlining all the configuration management. Again, mentioned a runbook before. We might have a 100-page binder that's often outdated. However, if you take all these and move it to a Docker file, it contains all the commands to assemble the Docker container. All the instructions are built in there, including the ports, the volumes, the network, environmental variables, health checks. All these things can be contained within a single file. And that file contains all those instructions. So what we've done is take all the infrastructure configuration, moved it out, and put it into a single file that can be run in an image. Again, we want to simplify these app configuration managers. We define all of these configurations inside the Docker file. And what this does is it eliminates the configuration drift. So we're no more patching code in place. We're always deploying something new. There's always a new deployment with new container images. And you can actually see the difference between the previous image with a Docker command. So we provide a set of command line tools for you to manage the images. And so here is
here is an example. So where if you look at the classical way the runbooks are done, this is very classical way of deploying a Java application. You'll say install the VirtualBox. This is a real example that one of my friends built. She was using this runbook to deploy a Java application essentially. Okay. Once we gave this talk at DockerCon US, a similar talk. But then essentially once they started learning about Docker Compose is a way by which you can run multi-container application on multiple hosts very easily. So essentially, their runbook got converted in just a Docker Compose file. And look at the amount of productivity. This is from their live data. Typically, with the runbook, it'll take them 4 hours, exact same application, but they will take them 4 hours if they are lucky, if everybody is following the instructions, putting in the right set of credentials. But with Docker Compose, they automated everything. But just the application delivery was so quick without any change to the application. So there are parts and pieces that you can pick up as we saw in the keynote. Look at the places where you can start modernizing your applications. Now, you're not even changing anything to the application, but you're making the pipeline more effective.
And finally, moving to Docker E will improve your asset management. You can centrally manage all your containers in a private registry, or make you put it in public registry, and keep a record of all the versions by tagging it of all the images that are available. So what does this do? It improves your your app operations. All your deployments, your rollbacks, all are built in with application reliability. So you're able to do rolling updates to reduce the risk of new deployments. You have built-in health checks. You can reschedule containers in terms of when it fails. And you can copy or paste a single command just to deploy apps and define the state of the application. So one of the other legs of our program is portability. And with Docker E, we ensure hybrid cloud portability. We can deploy the application anywhere. As Arun has pointed out, we can do it in Swarm, we can do it with Kubernetes, we can do it in ECS. So applications can move across multiple infrastructures, whether it's on-prem, whether it's a hybrid, or in general, just it's portable, the infrastructure is agnostic. So if you look at the container architecture, which provides this agnostic packaging, at the very bottom, you'll see all different types of operating systems from Linux to mainframes, cloud, AWS, Azure, any other public clouds, and also as well the host OS. And in between there is Docker running as container as a service with containers running on top of that. So you have multiple containers running in your environment.
And the good thing, from the previous slide is when we're talking about container as a service, yes, it could be Docker EE, but after this morning's announcement, it could be, Kubernetes, for example. Or if you think some other orchestration service or other platform would fit your need, the key idea is to think about how do you want to start modernizing is take your application, containerize it, and then get onto that path.
So ultimately, we get infrastructure flexibility and portability. So starting from dev, you build your applications, or you modernize your applications within that container. And you can check it into a registry, have it scanned for security, make sure that it passes all current CVEs, then move it into your test environment as well. From there, you can move from test into prod, and in between, again, have it scanned.
So my question to you is, in that case, if I'm a Java developer, my source of truth is typically a jar file. Are you telling me with this, my source of truth is going to be now the image?
Exactly. that's what's going to happen. So the image which you produce in development with all the configurations that there, it will be part of the image. The image is mutable, and so that will be what's pushed to test, and they'll be pushed with prod. This eliminates the problem of works on my machine.
Right, and so as you are building new jar files, then essentially what you do is you create different tags, and those image tags essentially get pushed out to your registry, and then the same tag gets through the entire pipeline part of it.
So finally, security. We've been talking about security a lot, and reducing the risk profile. Again, we provide a much more secure environment through scanning of the base images. We reduce the surface area of attack, and we manage all the vulnerabilities by providing encryption both on the network as well as secrets management. So what Docker EE does is lets you run your applications in the most secure environment available. And it's secure by default out-of-the-box configurations. There are a number of features such as cryptographic node identity, mutual TLS across all the nodes, so that's always encrypted, transparent and automatic cert rotation. If you want to put in LDAP, external CA integration as well, or certificate authority, and you can also encrypt the traffic from container to container.
And I think the key part, again, after this morning's announcement is this is exactly what is made available to you as part of Docker Swarm, for example. That's still doing the cluster management. But then behind the scene, you can use Docker Swarm mode as an orchestrator or Kubernetes as an orchestrator. But all of these security features, if you were to set up your own Kubernetes cluster, could take some time to figure out how these need to be plugged in together. But now you're going to get that as part of Docker EE.
So once again, we make apps safer with vulnerability scanning. The scanning is performed at the binary level of the application, and it provides detailed bill of materials for the security profile of the application profiles. So you're able to make these informed decisions about what should be there, what should be used, and the bill of materials is also maintained and continuously monitored against NIST CVE database. And finally, one of the things is access. So we provide granular access control for users, apps, and nodes, so we can restrict all the access to apps and resources, and use custom roles or predefined roles to manage access to the permissions, and create logical and physical isolation between apps and teams. So finally, to leverage a secure and automated software supply chain, what we do is we establish a chain of trust with the apps as they move across from the environment. All the containers are digitally signed and run only verified containers. And there's always freshness guaranteed, which ensures that there's no tampering and the latest container is always running, the latest container with the latest security patches. And we automate the entire workflow with immutable repositories and automate the image promotion.
Now, in this case, it's automated image promotion, but this could be at any point of time be manually triggered as well.
Of course.
Because I may not feel comfortable. It's a legacy app. I want to have a manual check, and also you can actually have a human click a button that now take it to production. So all the things that you would typically expect from a container workflow are available, but not just restricted to your newer applications, but for your legacy applications as well. The key part being you first look at containerizing the application, and then you leverage all the benefits that comes as part of a container workflow processing model.
Okay, so let's talk a little bit about the MTA process, or the Modernizing Traditional Apps process. So we have this diagram we use internally, and we also show it to our customers and clients. First, we'll start with an existing application, and we talked about this earlier in the keynote, about something, a monolithic app, such as a Java monolithic app, and taking that without changing the code. And what we want to do is move it into a container. We'll make that possible. And we'll demo this in a bit.
Now, when we are converting to a container, essentially, if it's a jar file, then you are taking a look at, okay, the jar file needs to be distributed. Then you will typically pick a base image. Then you're taking a look at what the base image should be. Should I be using the OpenJDK image? If I'm picking the OpenJDK image, do you really need the JDK? Or can I use just the JRE? So you're looking again at how do you build those effective images, or can I use the JRE Slim? And you start looking at those variable factors on when and how you need to build that image so that it stays very effective. Now, of course, there is Docker Maven plugin. I particularly like the one by Fabric 8 guys, which is by Red Hat. So I use that Docker Maven plugin pretty effectively, pretty much in all my projects. You can either use Dockerfile to create, your Docker image, or as part of your Maven workflow itself, you can say, just pick this jar and put it as part of your Maven workflow itself. Say, create my Docker image, or even Gradle plugin. There's a Gradle Docker plugin as well. So with either of those plugins or hardcore Docker file, you can actually create that content. If you want to learn more about it, there is a workshop on github.com/docker/labs. Take a look at it over there. We talk about the Docker Maven plugin, the Gradle plugin over there, in order just to get you started over there.
That's great. So once we get our container moved into, or our application moved into a container or an image, we can deploy it on modern infrastructure. Basically, you can deploy it on Docker, again, deploy it on Kubernetes, and then we can use our Docker Trusted Registry to share the image, and also give it a place to be scanned as well, and integrate it into a CI/CD pipeline, and have the image actually rebuilt every time your team pushes new code into a repository. And finally, you can push it out to a modern microservices environment and add new services and start peeling off some of these other services from this monolith code database. So we know we're not going to always stay within this code database, but perhaps what we can do is to move forward is to peel off functions from that data, from that application, and then move forward with modernizing the application.
And one of the key things, if you go back to the previous slide, sure. I think one of the key things over there is, as you are building your applications, hopefully when you are building newer applications, you're already adapting the container methodology. So whether it's a legacy application or a modern application, for both of them, you can continue to leverage your modern infrastructure, whether it's running on premise or hybrid or on public cloud. Wherever it's running, you can continue to leverage that. And as Sophia explained, once you start building that application, certain times it may not be possible to actually peel off the functionality, in which case you start refactoring the application somehow, that, OK, I'm going to start turning off switches. But you really have to think about how much knobs and levers that the legacy application really provides, essentially. And based upon that, you may even consider rewriting the application, that, OK, I'm going to turn off that application, I'm going to rewrite that application. Certain times, you have to kind of bite the bullet and go that route. But I think one of the key things that I do want to highlight is, when you're talking about modernizing traditional applications, rewriting every time may not be possible. In certain cases, you may not have any understanding of what the underlying logic or the code does. So packaging it as is, as a container, is maybe going to be your best bet.
So let's break down what how we achieve any deployment savings by modernizing your application. Before, we want to take it offline, then we want to deploy it, then make any changes, smoke test it, do an acceptance test, and finally get a go, no-go. And this can average out to about 100 man-hours. With modern app deployments, what we can do is take it offline, deploy it immediately, perform an acceptance test, and just give the go, no-go. And you can probably do this within 24 man-hours easily. So let's talk about monolithic Java applications as to preceding this. Yeah, well, as I said, my background goes all the way to J2EE 1.2. So there's this dyno floating around in the hall, which is talking about legacy applications. So I just took this picture. One of the applications that we're going to use today is an application that I wrote, believe it or not, 4 years ago, and that's a legacy application. It's a Java EE application, essentially. But what we wanted to show is, it's a legacy application. Yes, we have the source code today, but in most of the cases, you may not have access to the source code. So what we'll do is we'll take a look at the application, we'll show you the existing code, and then we'll show you how we migrated it. We'll show the process of taking that application, containerizing it, and making it go through the pipeline. OK, so demo time here. Actually, this is we can look at DockerCon. Is it dockercon.com? Yeah, it's dockercon.com/labs. And if you go there, there is a link over there which takes you at the bottom of the page, which says exactly that, here I have an environment set up, and then you can actually practice the workshop by yourself. Mm-hmm. Oops. So is that showing? OK, so we're doing this on Play with Docker. So, Sophia, what is Play with Docker? Play with Docker is a Docker environment that you can run in your browser, which is fairly amazing. So it basically gives you 4 hours to test and deploy your Docker applications and run in there. And it's pretty fully fledged as a Docker environment. So you don't actually even have to download Docker to your local machine if you just want to try it out. So you can run labs here, you can run all sorts of things. So the first application, Arun actually wrote this application for an O'Reilly book at first. So it was a Java E7 O'Reilly book. And so I found it, and I was like, hey, this is pretty cool. Arun wrote this a while back. And I was looking for a Java EE app at the time. So what he originally had built was something that worked on Wildfly. And what I did was I took that original application, and I created a Docker file for it. And I know that we've been mentioning earlier that we don't actually have to recode anything or recompile anything. You can just deploy a jar file. And just for simplicity's sake, I put it up into a GitHub repo, took the code, and actually build the code with Maven in Docker, with a Docker container, a Docker image, and build it there. So my tool chain is like, I don't even have Maven on my machine. It's just running in Docker. Then I copied the WORA file that's produced from there and moved it into okay.
Yeah, well, in this case, it's a Java EE application. So essentially, we are choosing Wildfly as the base container, but we could have picked up any Java EE compatible base image and then say, okay, use Tommy Tribe, for example, or Glassfish, whatever the Java E7 compliant application server is. Use that as a base image, pick up that WAR file. In that Wildfly container, this is where the WAR file needs to be deployed. So you deploy it over there, and then you build the image. Now, Sophia, do you think the Docker application converter that was talked about this morning would help anyway in this particular scenario?
That actually would be perfect for it. Unfortunately, it's in private beta right now, and it should be released later this year for people to use. But the Docker application converter will actually look at an existing WAR file and determine all the different pieces that are there, or an application. Actually, it'll look at an image of a virtual machine image, and then detect all the parameters. Let's say if you're running on Tomcat, detect all the parameters, all the Java ops type stuff, and also where the WAR file is, or any other applications there, and reproduce it, and then write out a Docker file, which you can automatically run.
So all the work that you did manually would no longer be required with Docker application converter because machines are automating our work.
Exactly. It's like I wouldn't actually have to spend time figuring out how the application worked. So this is the original application. It's running on Wildfly. Yep. And are you proud? You feeling proud?
I'm not a GUI guy, so don't blame me. I'm a server-side person. I just wanted to make sure my server-side logic is showing up in my front end. And JSF was the best GUI, not the best GUI, but JSF was the best GUI I could come up within the Java EE landscape.
So one of the functions in this application is that it shows you a set of movies. And as you can see, it's listing all the movies that are available in the Movieplex. And if you're interested, you can also get a few more details about the movie. Okay, there we go.
And so that's as fancy as this application gets. It's a legacy application, but that's my graphical skills.
Okay, so I took that and decided, well, this is 2017. It's probably should be a little bit fancier. And when I talked earlier about...
Show me the Docker file on how you created the image for that jar file.
Okay. Come on. Now let's try here. Actually.
So, in that Docker file itself, go back to that Docker file.
Okay.
So this is a multi-stage Docker file.
That's true. It uses a multi-stage build. As I mentioned earlier, it's using the multi-stage build, uses Maven, uses Maven to build the original WORA file, actually compile the code, build the WORA file that I will deploy to the second part, which is on the JBoss Wildfly app server.
So line 8, well, line 1 through 6 basically shows the first stage of the build, where it says, oh, I don't know how the file was originally built, but I'm going to use Maven, and I don't want to install Maven on my development machine, so I'm going to use a Maven image by itself. And when Maven is going to build it, it's going to download the whole Maven repo, but I don't want to package that Maven repo as part of my image, so I'm going to use a multi-stage build. In the first stage, essentially, I'm going to do the Maven stuff over there. It's going to download the repo. And then very clearly, I'm going to hand off from the first stage to the second stage. And the handoff is actually happening on line 11, where I'm saying, oh, copy from app, which is the stage 1, bring that WAR file, and drop it into the current directory. And then I'm saying, of course, on line 8, for the second and the final stage, here is my jboss/wildfly as a base image.
Yeah. So let's bring up the application that's been refreshed, and we talked about earlier about peeling off certain functions from an app, but we're going to keep the service app intact. We're not going to change the code there. And in Arun's foresight in 2013, he implemented REST, which was really awesome because that meant I can talk to the app server without having to do any type of integration. So just a very loose integration to begin with.
So in this case, the Docker file was used to create the image. And when the image was done, then you pushed it into a registry. And then you wrote handcrafted the Docker Compose file, which says, oh, this is my 2 services that needs to work with each other. And then you're saying, now Docker Compose, bring up that application.
Yeah. So let me go here. This is actually I redeployed it also and moved it out from Wildfly to Tomcat because we wanted to do it on an open source server. And finally, we added in a React client. So I wrote a new client in JavaScript to make it just a little bit more colorful. So here we go, Movieplex 7. You get to see, you get to see really old movies like The Matrix. And then you get cool stuff like, you get to see a little bit more of who the actors were. You can go to IMDb, find the ratings, and that kind of stuff. So the general idea is we've left the original application intact. It's up and running, but we're providing a new service for customers. I mean, we're having something that looks much more modern, more new, something that people can relate with more easily.
And then we are really leveraging Docker Compose, and this is all going through in this case, we're doing it in Play with Docker, but this could very well run as part of Docker EE, and all the benefits we talked about, security scanning, the automatic certificate rotation, all of that we're getting as part of it.
Yes, exactly. And ultimately, if you wanted to do this, you can run it as a swarm. So right now, I've deployed the entire app. I took the Docker Compose file, ran it as a Docker swarm. Here's our visualization tool that we usually use to show the different nodes that are on the swarm. So with the Movieplex 7 applications are running here, we have several workers that are actually the React client that was running earlier.
So this is a multi-container application running on multiple hosts.
Exactly. And this is an application that you wrote in 2013.
That's right. It's a dinosaur application.
Come on. Give it up.
All right.
Thanks.
Now, where can they find the source code for this?
It is on Docker Labs. So github.com/Docker Labs/ I think a Java EE-demo. And feel free to download it, work with it, make changes, send me pull requests, because I am not the best Java coder, nor am I the best React coder out there. And I believe some of our doc captains already made requests, so they've actually fixed my code. I'm really happy about that.
Right.
All right.
We have one last slide.
Yeah. Oops, sorry.
Well, you can reach out to us. Those are email IDs and Twitter handles. Feel free to talk to us, send us questions, comments. What do you think about the process? How do you think this could be better? How do you think this could benefit you?
And just a few quick plugs for modernizing traditional apps. If you want to stop by the booth, stop by the MTA pod there. You can also download the MTA kit with docker.com/MTA. We have a number of road shows that if you want to schedule for that, they're coming near you. And also you can contact your account team as well. We have a hosted demo as well, so docker.com/trial. If you want to try out the features of Docker EE, we have a 4-hour demo. There are no servers required, just run it. You have full Docker EE access. You know, you have DTR, you have UCP, and all those acronyms that go along with Docker.
All right, that's a wrap.
Yeah.
I'll shout it. How about distributing Oracle JRE? Are we breaking the law? How can we bundle that for our customers?
I don't think I can answer that. So there is a Oracle JRE on Docker Store. Yeah. So that's where you can ask people to download it from. Or there is a Oracle Container Registry where typically people download it from as well.
Yeah, there's isn't they moving to OpenJDK 2 as well in 9?
Yeah.
So.
It's all available. And again, we're not really lawyers per se. So typically what we have seen, at least the way I've seen this customers taking into production is they have a JDK license, and then they say, I'm going to base my image on OpenJDK JRE, for example. And then they say, I'm going to download it because you have to click through the license and all those things. But I'm not a lawyer, so don't quote me on that.
Yeah, exactly. Any other questions, please?
Yeah. So why don't we wrap it up and then maybe huddle up here, ask questions that way. Yeah. Thank you, guys.